So we are going to look into February-March paper 2025, paper 2. So for the first question, if we look at phosphorus and chlorine are elements in period 3 of the periodic table. Chlorine forms 3 different compounds. With phosphorus, the most compound, the most common compound is given. Now, using those information, we need to find the oxidation number. So we can calculate the oxidation number quite easily. So phosphorus, X, plus chlorine is -1, so 3 times -1. This is going to be 0, so X equals to +3. So please write down +3. Don't write 3. Do not write 3 plus. So oxidation number of Cl, yes, is going to be -1. For this, this is going to be -1. So PCl5 is X plus 5 times -1 equals to 0. X equals to +5. So this is going to be +5. Now, in a closed system, PCl3 and PCl5, they exist in an equilibrium mixture as shown in reaction number 1. Deduce 2 conditions that favors the production of PCl5 in reaction number 1. So something that can actually bring them to the right hand side. The position should be shifted to the right hand side. We know that if you put the hand over here, as I taught you, this is negative, this is going to be hot. This one is going to be cold. So if you want to go towards hot, you need to bring the temperature down. Because according to LCP, temperature down, you need to increase the temperature, so you are going to move forward. So one condition, is going to be low temperature. Low temperature. Now, second, if we want to talk about, let's say, for example, pressure, that we only look into gas. There is only 1 mole, of chlorine over there, so it's 1 here. There on the right hand side, there is no gas, so it's 0. So we want it to move from 1 to 0, reduce the number of moles. How do you reduce the number of moles? You can do that by increasing pressure. If you increase pressure, what will happen? According to LCP, pressure is lowered. So how do you lower pressure? The lower pressure is you move from more number of moles to less number of moles, which is going to be valid for this case. So what you need to do, you need to have high pressure. So these are the 2 conditions that will favor the production of PCl5, in reaction number 1. Now the third compound, phosphorus and chlorine, has a relative molecular mass between PCl3 and PCl5. So they say between them, between them. Now the compound contains 69.6% by mass of chlorine. So let's actually determine the molecular mass. So should be P and Cl. The percentage is 69.6%. So this one is going to be, let me check again what that matters. Now, so if it is 69.6%, so this one will be 30.4%. 30.4%, that is going to give you 100%. So what we need to do now is to divide this, with the MR, the AR, CL, you can check quickly. CL is going to be 35.5, phosphorus is going to be 31, So we just put over there, which is going to be 35.5 and 31, We take the calculator and calculate. So 30.4 divided by 31, you get 0.981. 69.6 divided by 35.5 is 1.961. So straight away you can deduce is 1 to 2, but let's say you don't want to do that. We can still divide by the smaller number, 0.981, 0.981. So you will get 1. Okay, so this one divided by 0.981, you will get 1.999. Okay, now we know we can deduce to 1 to 2. Okay, so the molecular formula, okay, before we determine that, empirical formula wise is PCl2, that is empirical formula. Now, we know PCl3, okay, and PCl5. P is 31, 3 times Cl, 3 times 35.5 plus 31, okay, this is 137.5. The MR of PCl5 is 5 times 35.5 plus 31, that is going to be 208.5. Okay, they say it is between, okay, between. Let's actually just simply calculate this. Okay, this is going to be 31, okay, plus 35.5 plus 35.5 is going to be 71. So it's going to be 102. Okay, now 102 doesn't come in between. Okay, 137.5 and 208.5. So what you can do, maybe you can times by 2. Okay, times by 2. So if you times by 2, you will get 204, which is in between. Okay, which is in between. So we can deduce that it's supposed to be times by 2. So the molecular formula is P2Cl4. Okay, so this is how you determine. Okay, times by 2. So if let's say you times by 2 also it doesn't come in between, then what you need to do, you times by 3 and so on, you try. Yeah. Now next, okay, W is a liquid at room temperature and pressure. Okay, so P2Cl4 is a liquid. It reacts vigorously with water to form an acidic solution. Suggest the structure and bonding in W. Okay, so do take note, P2Cl4, non-metal, so it's going to be a simple molecular. Okay, simple molecular, that is the structure, simple molecular. Okay, and the bonding, okay, because here, okay, you say they say that it's going to be liquid at room temperature and pressure. Okay, the melting point is going to be low. Okay, so because the melting point is low, okay, the bonding between them, okay, this is going to be, you can also tell also, because the melting point is low, okay, melting point, okay, is low. Okay, if it is melting point is high, okay, then it's going to be solid. Okay, in this case, melting point is low. Okay, therefore we can deduce a simple molecular. Okay, because it has, okay, it has weak, okay, van der Waals forces, VDW, if you want to write. Okay, because they have weak van der Waals forces. Because of that, I can deduce this is simple molecular. Okay, now. In terms of bonding, okay, in terms of bonding, because they react vigorously to form acidic solution, it means that they become hydrolyzed. Basically, they are reacting with water. Okay, hydrolyzed, okay, broken because of water. Because of that, okay, the bond must be weaker bond. Okay, so should be covalent bond. Okay, so in this case, okay, this is a covalent bond. Okay, because can be hydrolyzed to form acidic solution. Okay, or you can also mention it's going to be non-metal and non-metal, therefore is covalent bonding. But in the marking key, they didn't mention non-metal and non-metal. Okay, in the marking key, they mentioned, okay, because they can be hydrolyzed. Okay, because they can be hydrolyzed. Anything that is reacting with water, okay, they become hydrolyzed. And in order to become hydrolyzed, okay, it should be covalent bond. Okay, covalent bond. Then how come if it is going to be ionic? Yeah, ionic, they just dissolve. Okay, to give you, let's say for example NaCl. Okay, aqueous. So they will give you Na plus and Cl minus. Okay, so there is no reaction over there. Okay. okay, they just dissolve. Okay, hydrolyze in means it breaks the bond and reacting. Okay, now B. Figure 1.1 shows a reaction scheme involving P4 and Cl2. So you have P4, okay, and then you have all these reactions and so on. Suggest what is observed in reaction number 2. Okay, so here, okay, I have P4, okay, changing into, okay, PCl5, okay. So we know, okay, the color of Cl2, okay, what is the color of Cl2? Not yellow, yeah. So greenish yellow or green, you can choose, yeah. So generally the greenish yellow, okay, or in the marking key they mention green color, okay. The green color disappears, okay, because the Cl2 is reacting. So you can say the greenish, okay. I will stick to greenish yellow, yeah. The greenish yellow color gas disappears. Okay, the color disappears. Okay, predict the shape of PCl5. Now, phosphorus is group 15. You can check from the periodic table. So, if you have, okay, Cl5, then the structure should be, okay, something like this. Okay, Cl, 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 then down Cl. So, what kind of structure is this? This is, because in the middle is trigonal. Then you have two like pyramids on top and below. So it's going to be trigonal bipyramidal. Okay, trigonal bipyramidal. Okay, because they have 5 bonding pair. Okay, now write an equation for the formation of A in reaction number 3. Okay, so reaction number 3, P4. Okay, P4 reacting with O2 to give you A. Okay, so generally you should know this. Reacting and a phosphorus with oxygen will give you the oxide of phosphorus. The oxide of phosphorus you must memorize P4O10. Okay, P4O10. So it means P4, okay, plus oxygen to give you P4O10. Okay, you balance this. Okay, so this one should be 5. You want to write the state, if you know, you write. If you don't want, you can just leave it. But in this case, since I know, I just put solid, gas, this is going to be solid. Okay. Now, name B, which is formed in both reaction 4 and 5. Okay. Reaction 4, okay, and reaction 5. We want to name this. Okay. Just now we already found out. Okay. A was P4O10. When you react with water, okay, generally you should know that they will give you H3PO. H3PO what? PO4 or H3PO3? Should be PO4, yeah, phosphoric acid. Okay, phosphoric acid. Okay, H3PO4. Okay, so the same thing also PCl5. Okay, when you react with H2O, they will give you H3PO4. Now your work is you do not just say phosphoric acid. Please find out what is going to be the oxidation number of phosphorus over there, because you also can have H3PO3 and so on. So phosphoric acid, okay, phosphoric acid, please find out what is the number here. How to find out? Okay, H3PO4, okay, so 3 times 1, okay, plus P is X, then 4, oxygen is negative 2 equals to 0, 3 plus X minus 8 equals to 0, X minus 5 equals to 0, X equals to plus 5. So please write down V. Okay, the oxidation number is going to be for phosphorus is 5, okay, plus 5. So phosphorus V acid. Okay. Now draw the structure of C used in reaction 6. Okay. So we want to know what is C. Okay. What is C? In this case, you have PCl5 reacting with something. Okay. That gives you this. Okay. You can see there is 2 carbon there. Okay. So sorry. It is PCl5, yeah, correct. PCl5 reacting with something, okay, to give you this, okay. So what reacts with PCl5? Okay, I think similar to ACl, SOCl2, okay, and then PCl3. The only thing that requires heat is PCl3. So these four regions can react with something. What is that? Alcohol, okay. It will react with alcohol, okay, where, okay, it will give you this structure, okay. The formula is going to be something like this: ROH plus PCl5, it will give you RCl, okay, plus what? Let's write down all the equation involving this, okay. RCl, okay. Do you get, okay, PCl5 is a test for alcohol. So you must have white fumes of gas. So there must be HCl. The remaining should be something that has 3Cl. So it should be what? POCl3. Yeah, please remember this, yeah? POCl3. Okay. Now, if you have ROH plus SOCl2, okay, you will get two types of gas. You will get RCl plus SO2 plus HCl. Then you balance it up. Okay. Now, you can also have ROH plus, okay, PCl3. You will get two products. One is RCl, another one is H3P. PO how many? Okay, H3PO3. Okay, you will get this. And then if you balance this, okay, you should get 3 over here and then 3 over here. Okay, and the last one, ROH plus HCl, you will get RCl plus RCl and H2O. Okay, so all these I have written for you. Okay, so now, okay, in this case, the C should be something that has alcohol. Okay, but there is 2Cl. It means these 2Cl part must have OH and OH. So if I draw, it should be like this. Replace this with OH, replace this with OH. That's it. Okay. So here, okay, they say draw the structure. Always draw with the same structure that they gave you. Okay. In this case, skeletal formula. Okay. So I can take this, okay, and I paste it over there. Okay. Paste. Okay, make sure, okay, you draw, okay, if you want to draw nicely, okay, like this, okay, OH, OH, okay. Now, C. Here we have, okay, 1,2-dichloroethane, which is similar just now. Okay, I can rewrite this, okay, 1, 2, okay, and then Cl, okay, hydrogen. Reacts with sodium hydroxide, okay, it reacts with sodium hydroxide to produce an unsaturated compound. Unsaturated compound means it has double bond, okay, carbon-carbon double bond. The only way that it can give you unsaturated compound with NaOH is through elimination reaction, which is going to be the NaOH must be in ethanol, okay, must be in ethanol. Okay, as shown, okay, state what is meant by unsaturated. Okay, it contains, at least, okay, at least one, okay, carbon to carbon double bond. Okay. At least one carbon, okay, because sometimes we tend to write like this, okay. I don't want like that. Maybe it can be misinterpreted. Okay, you can say it contains at least one carbon to carbon double bond, okay. or it can be also triple bond, okay, but I think in this case if we mention double bond is still okay, okay. Now state the condition for reaction 7, okay. So the solvent, okay, remember your test that I gave you recently. The solvent is the what is you put to dissolve sodium hydroxide, okay. The solvent should be, okay, is ethanol, okay. Do you need heat? Okay, do you need heat? Must be heated, okay, must be heated, okay. So solvent is ethanol, you need to heat. In fact, okay, all the reactions, okay, involving the nucleophilic substitution, okay, it must be heated as well, okay. So starting from sodium hydroxide aqueous, okay, then we also have ammonia, okay, heated with under pressure, yeah, ammonia in ethanol, and then we have one more KCN in ethanol, okay, and then you have NaOH, okay, in ethanol, okay. All these, okay, all the 4 reactions must be heated, okay, must be heated. So what happens if I just say solvent is ethanol, didn't include heat? You'll get 0 marks, yeah. Must be with ethanol heated, okay, must be heated.
Sir, if you read the ethanol and the OH is still okay.
Ethanolic, yeah, because depends on the question. They say that condition. So condition is not ethanolic NaOH because the region is already NaOH. So the condition is ethanol. So just write ethanol solvent or ethanol. Okay, don't write. No need to write NaOH. Okay, because NaOH is the region. Okay, it's the region. Even in the marking key, they don't put NaOH. Okay. Now for D, this one we recently studied. Okay, related to this. So this is going to be mass spectrum. You can see in the past year paper how they are going to test the chemical analytics over here. Okay, at least you see they are giving 2 marks here. Okay, they relate to the question above. So here they have, okay, mass spectrum of D. Okay, D contains carbon, hydrogen, and chlorine. Okay, carbon, hydrogen, and chlorine. Okay, so here, okay, I need to explain the relative abundance of peak 1 and peak number 2. Okay, just about relative abundance. Okay, just relative abundance. So you can see here, you don't need to tell what is it and so on. Just abundance. This is 100. Okay, you can see from here 100. And if you count from here, it's going to be about 31 around there. Okay, 31 around there. Okay, so maybe about 30, yeah. So here, what can I tell about the relative abundance? Okay, the relative abundance, okay, is going to follow the ratio. Okay, relative abundance of 2 to 1 is following the ratio of, if you say 2 to 1, then it's going to be 1 to 3. If you say 1 to 2, then the ratio is going to be 3 to 1. Okay, so depending on how you relate. Okay, now suggest the structure of D. Okay, so the structure of D, okay, we need to suggest. Okay, so compound D, let's see whether we have any hint over here. Okay, no. Okay, compound D. Okay, so this one, okay, if you look at these values, okay, we have this. Okay, compound D we want to identify. Okay, compound D contains carbon. Is there any other information about compound D before? Okay, no information about compound D. Okay, I think here also no information. So just It's going to be a standalone a bit. Okay, compound D contains carbon, hydrogen, and chlorine only. Now, here, okay, the chlorine, okay, if you have carbon, okay, hydrogen, and chlorine, so we just want to find out, okay, if you want to know the information over here, you want to solve, you need to know the molecular ion. Okay, molecular ion. Now, can you find out which one is going to be the molecular ion? There are going to be total 4 peaks over here. Okay. So if this one is going to be M, okay. So this one is if we follow this as M, this is going to be, we learned in the past, okay, M plus 1 peak, M plus 2 peak, okay. We also learned a little bit about M plus 4 peak, okay. Now, definitely M plus 4 is not in this, okay. But let's say M plus 1 is going to be very small, okay, very small. M plus 2 is the one that you can have when you have chlorine 35 and then chlorine 37. Okay, in this case, it's going to be the one that is going to have, okay, this chlorine is related to this this peak, yeah. So M plus 2. Okay. Now, if this is going to be something to do with M plus 2, okay, M plus 2, which one do you think will be M? Is it 60 or 59? Definitely this is M plus, yeah? M plus 1. Okay? If M plus 1, then should be 60 lah. Okay? 60 should be the molecular ion. Okay? 60 should be the molecular ion. Okay? So this should be the molecular ion. Okay? The molecular ion is at 60. So we need to find out what combination, okay, can give us 60. And that 60, within that 60, you must have 1 Cl. Okay? Cl is already 35.5. Okay? Cl is already 35.5. If I have only one carbon Cl, and then hydrogen, okay, because they say hydrogen and carbon only, I will have 12 plus 3 plus 35, sorry, it's not 35.5, yes, we will follow 35, chlorine 35, okay, chlorine 35, chlorine 37. So this one will be involving chlorine 37. This one is going to be involving chlorine 35. So if we follow chlorine 35, okay, so this should be 12 plus 3 plus 35 is going to be 15 plus 35. That's going to be 50. Okay, cannot be the answer. Okay, cannot be the answer. We are looking for 60. Okay, so we need to include another carbon. Okay. And you must have another Cl. But if I have all single bond, what will happen? Okay, that's going to be 35 plus 12, 24 plus 5. That's 29 plus 35, which is going to be 64. Cannot be. Okay, but we need less. Can you get less than that? Of course you can. You can try carbon, double bond carbon. You can have Cl over there. You have one hydrogen here. So that's going to be 24, 12 plus 12 plus 35 plus 3. What you will get? Okay, you will get 62. Still not enough. Okay, you want 60. What you can do? Try triple bond carbon. Okay, triple bond carbon. You have Cl over there. You have one hydrogen. What happened? 24. Okay, 12 and 12, 24 plus 1 plus 35. that is going to give you 60. Okay, so suggest the structure, okay, of D. Okay, in this case, I will suggest the structure to have triple bond. Okay, you want to draw like this also can, or you want to draw using skeletal formula also can. Okay. Okay, let's continue. So for question number 2, okay, we are going to look into group 2 elements. Okay, it contains metallic bonding, define metallic bonding. So please remember, when we want to define metallic bonding, is the electrostatic forces of attraction. Forces of attraction between, okay, metal cation and the C of delocalized electrons. Okay, so please remember to write down like this. Okay, so it's the electrostatic forces of attraction. Okay, that will give you 1 mark. Okay, metal cations, okay, and the C of delocalized electron. Okay, let's move on further. The group 2 elements, okay, form stable 2+ cations. Okay, state and explain the variation of ionic radius of group 2 elements down the group. Okay, going down the group, generally we notice that the number of shells are increasing. Okay, the number of shells are increasing, and when you have +2 cations, okay, it means that 2 electrons are gone. Okay, let's say generally, if you have period number 1, okay, period number 2, okay, period number 3, and so on. Okay, and we know that, okay, when you have +2, okay, the shells also decrease generally, but the size, okay, of the ionic radius will still follow a particular trend, okay, which is the trend is going to be, we know that is going to increase down the group. It follows the same as atomic radius, but the difference is each of them, they have less one shell, because they lose the 2 electrons. Okay, so the variation of ionic radius, okay, increases down the group. Okay, increases down the group. Okay, because, okay, the reason is going to be because +2, okay, is going to be less, okay, although less number of shells, okay, the distance and shielding effect, okay, distance and shielding effect still outweigh the increase in nuclear charge. Okay, therefore the trend remain increasing down the group. Okay, let's move on. Okay, table 2.1, okay, is going to be showing successive ionization energy values for beryllium, and we can see there is going to be a significant increase, okay, from here to here, okay, from 2000 to become 14,000. There is a big increase over there, so it means that the third electron, okay, must be in the inner shell. So inner shell, so outer shell contains 2 electrons, okay, therefore this must belong to group 2. So explain, okay, the general trend in this value. The general trend, okay, okay, of ionization energy is increasing, okay, increasing. Okay, why? Okay, when increasing, because okay, we know that the shielding effect, number of shells remain the same, so shielding effect is constant, but okay, nuclear charge, number of proton increases, therefore the nuclear charge, okay, the nuclear charge, or rather than say nuclear charge, yeah, you can say the nuclear charge increases, greater attraction of electrons to the nucleus, okay, difficult to be separated, okay, so you can explain that, okay. The significance between second and third, okay, so you just need to tell the third electron is at the outer shell, which is the second electron is removed from the inner shell, which has, okay, a higher energy level, okay, higher energy level, to be removed. Okay, you require more energy to remove the third electron. Okay, so here the third electron, okay, sorry, you have you need to, yeah, correct, you need to remove the third electron from the inner shell. Okay, the third electron is at inner shell. Okay, the third electron is at inner shell, which is, okay, remove, okay, I think inner shell, so you can cancel this. The third electron is at inner shell, which has, okay, which has higher energy level, okay, or which requires high energy to be removed. Okay, so because it's in the inner shell. Okay, now, so 2 marks. Okay, C, beryllium, okay, at the group 2 elements except beryllium have more than one stable isotope. Beryllium exists as a single isotope, okay, so which is going to be 9 and 4. Okay, describe the distribution of mass within the atom of 9 to 4. So basically the mass, okay, is going to be the mass generally is 9. Okay, so beryllium, okay, is 4, so it's supposed to be 1s2, okay, 2s2. Okay, so they are total 4, so they are in the, okay, if you look at the at the electronic configuration, they are more towards, okay, in the principal quantum shell number 1 and principal quantum shell number 2. So the distribution of mass within the atom will be more in the in the nucleus, okay, because the proton and neutron are found in the nucleus. So you can see here, if you have 9, 4 beryllium, okay, number of proton is 4, okay, number of neutron is going to be 9 minus 4 is 5. Okay, so we know that mass, okay, the mass is going to be number of proton plus neutron. Okay, and and since we know that, Okay, neutron, okay, neutron, they stay, neutron and proton, they stay in the nucleus itself. Okay, so most of it, okay, is going to be coming from the nucleus. Okay, so you just say most of the mass is in the nucleus, because proton and neutron are found in the nucleus. To be exact, I think all the atoms are like that as well. Yeah, so we can just say, okay, describe the distribution of mass. Okay, the mass is more towards the nucleus. Okay, because proton and neutron are found in the nucleus. So electron, okay, will have minimal contribution to the mass. Okay. Now, complete the table 2.2 to show the number of proton and neutrons in the isotopes of magnesium. So do remember, proton must be the same. Magnesium is always going to be 12. So 12, 12, 12. If you have 24, magnesium 12, 25, magnesium 12, 26. Number of neutrons will be different. So the first one, the number of neutrons is 12. You minus here is going to be 13, and you minus here is going to be 14. So isotope have the same number of proton but different number of neutrons. Okay. Now figure 2.1 shows the behavior of a beam of a proton in electric field. And label your diagram clearly. Assume that the beam of each particle are moving at the same velocity. So we want to label. Okay, so we want to label. Okay, so let's see, complete figure 2.1 to show the behavior of separate beams of neutron and electrons. Okay, so they have given us the proton. Okay, so please take note, neutron, they don't get deflected, they will move straight. Okay, so this is going to be beam of neutron. Okay, and then if proton going up, okay, proton is positive, so they will go to the negative. So this one is positive. So electron will move to the positive, but the shape, okay, do remember, because electron is going to be, the mass is going to be less, okay, than the proton, it will be deflected a lot. Okay, they will be deflected a lot. So we can just put deflected before beam of proton. Okay, because of the mass which is less. So this is beam of electron. Okay. Now that's going to be 3 marks. Okay. Now state what is observed when hydrochloric acid is added to barium oxide and barium carbonate. Okay, barium carbonate, barium oxide. Okay, group 2. Yeah, so group 2, okay, they are basic oxides, so they can react with acid. Okay, so you will get barium chloride, okay, plus, okay, H and O supposed to give you okay, H2 hydrogen. State what is observed. Okay, what is observed. Okay, so we want to know what do you see. Yeah, what do you see? So this one, the equation doesn't matter. Okay, so I still will write down. Okay, so here it will give you H2O, okay, barium oxide, okay, plus ACl. Here barium carbonate plus ACl, they will give you barium chloride, okay, plus carbon dioxide and water. Okay, so here, okay, what do you see? Okay, this one is colorless, you cannot see anything. So barium oxide is solid. Okay, barium carbonate is also solid. So you can mention that the white for barium oxide. Okay, I don't see any other thing. Okay, so maybe I can just say the white barium oxide is white solid. The white solid disappears. Okay, the white solid disappears. Okay, wrong spelling. Okay, white solid disappears. Barium carbonate, okay, do remember barium carbonate gives you gas. Okay, so you will have effervescence. Okay, effervescence. Okay, and okay, you need to also mention the white solid disappears. Now write an equation for the reaction of strontium with cold water. Okay, so strontium, okay, will react vigorously, okay, with water. So they will give you strontium oxide plus hydrogen gas. Okay, so strontium oxide plus hydrogen gas. So it's already okay. Let's check whether, sorry, the one oxide is going to be like this. Magnesium, okay, when react with H2O, okay, it can react Mg if it is cold condition and hot condition. Cold is magnesium hydroxide plus hydrogen, okay, but this one is magnesium oxide plus hydrogen. So we will actually focus on the more vigorous reaction, so it should be SRO, not OH anymore. Yeah, so plus, okay, plus H2, okay, plus H2, sorry, this is hot, okay, strontium hydroxide, sorry. Okay, so they will follow the normal one, which is going to be follow the hydroxide. So strontium hydroxide, okay, let me erase again. Okay, so they will follow strontium hydroxide, okay, plus H2. So now if you balance it up, okay, you will get 2 over there, then it's balanced. Okay, now state the variation in solubility down the group. So please remember, barium sulfate, okay, it's going to be a white precipitate. So of course we want to expect the lower the barium sulfate, which is lower at the group 2, they are going to be solid. So it's going to be solubility decreases. Okay, solubility decreases down the group. For sulfate, yeah. For hydroxide increases. Okay. Now next, question number 3. The halogens chlorine, bromine, and iodine show strengths of in chemical and physical properties down the group. So we have chlorine, okay, being a green gas. So this one, bromine and iodine. So this is solid. This is going to be liquid. Okay. So color and state, okay, so this one, bromine, okay, if it is liquid, it's going to be a brown liquid, okay, a brown liquid. And this one will be black solid. Now, complete the table, done. Okay, the bond energy values 3.1 refer to the XX bond, where X is halogen, okay. So explain the trend in bond strength, okay, in the halogen. Okay, so if you look at Cl to iodine, okay, the bond strength, okay, the bond strength, okay, the bond energy decreases, the bond strength decreases down the group for halogens. Okay, I just put the bond strength of this, okay, because you can say because you have smaller bond, okay, bond energy means, okay, the bond length, okay, is increasing down the group as the number of shell increases. Okay, so because of that, okay, the bond energy also decreases, easier to be broken. Okay, so we can just say, okay, bond length is increasing. Okay, the distance, okay, yeah, basically bond length is increasing because atomic size increases. Okay, easier to break. Okay, break the bond as, okay, as XX has weaker attraction. Okay, or rather than saying XX has a weaker attraction, you can just say easier to break bond as nucleus and okay, as it has weaker attraction between electron and nucleus. Okay, in the end, okay, it's 2 marks. Okay, so the moment you mention about, okay, bond length increases, okay, that is going to be 1 mark. Okay, easier to break the bond because weaker attraction is going to be 1 mark already. Okay, now explain the use of with the use of the equation, how chlorine is used in water purification. Okay, so chlorine is used to kill off the bacteria. Okay, so chlorine plus water, it will give you HCl plus HOCl. Okay, so the HOCl, okay, or the OCl minus from the HOCl, okay, is responsible to kill the bacteria. Okay, so this is going to be a disproportionation reaction. Okay, chlorine is going to be changing to two different product which has 2 different oxidation number. Now see, the sodium halides in table 3.1 also shows the trends in chemical property. Okay, identify sodium halide that reacts, okay, with H2SO4 to form H2S. Now the sodium halide that will react, okay, with concentrated H2SO4 to form H2S is going to be NaI. Okay, so NaI is the one that will react, okay, because we know that this will not react. Okay, you can prepare, okay, NaCl, okay, using you can actually react NaCl, okay, with H2SO4. Okay, so no issues. Okay, but if you are reacting NaBr plus H2SO4, it will give you HBr. HBr, okay, they can be changed, okay, from sulfuric acid will help to change HBr that will be produced from here, HBr, into it will oxidize HBr. Okay, it will oxidize HBr to become Br2 and so on. But when it comes to H2S, okay, the only thing that will actually give you H2S is going to be when you have HI. Okay, when they produce HI from here, okay, and AI plus H2SO4, okay, they will produce HI. HI can be further, okay, oxidized to become I2. It can give you H2S, okay. It can also give you this one I2, H2S, rotten egg smelling, yeah, or it can also give you sulfur. Okay, there are 3 products that you can actually get. Okay, so in this case the answer is NaI. Now identify sodium halide that only undergoes a Bronsted Lowry acid-base reaction, okay, with concentrated sulfuric acid. Now, if the Bronsted-Lowry's acid-base reaction, okay, does not undergo oxidation and so on, so the one that will actually do that is going to be only NaCl, because only NaCl will react to give you NaHSO4 plus ACl. That's it. Okay, ACl will not react, okay, be oxidized by sulfuric acid. Okay, so that's it. Now, a student adds a few drops of silver nitrate, okay, to a solution of NaBr. State what is observed. So silver nitrate, okay, with NaBr, they will give you silver bromide. Silver bromide is going to be a cream precipitate. A cream precipitate will be formed. Okay, so that's it. Okay, will be formed. Okay, a cream precipitate will be formed. Now, next. Iodine monobromide is a dark red solid that melts near room temperature. Okay, IBr reacts with propene. Okay, the mechanism is same as HBr with propene. Yeah, okay, so this one we are talking about electrophilic addition. Identify all the molecular forces that exist between the molecules of IBr. Okay, so IBr, okay, you see melts at room near room temperature. Melting point is low. Okay, if the melting point is low, okay, this is going to be weak van der Waals forces of attraction. But we know IBr, okay, is going to be different electronegativity between I and Br. Okay, therefore they must be having PD. Okay, permanent dipole. Okay, and okay, they must have, okay, ID. Okay, so PD and ID. Okay, so this one, okay, make sure you have both of them. They do not have hydrogen bonding. Okay, just this. Now name the mechanism involved with this. Okay, just now. Okay, electrophilic addition. Okay, electrophilic addition. Now the reaction of IBr with propene forms two structural isomers. Draw two structural isomers, okay, by shown by these molecules. Okay, so if you have, okay, so this one is propene. Yes, so propene, this is propene. So when I have IBr, okay, so you can have the double bond broken. So I will be here, Br will be there. Okay, another possible thing is going to be the double bond broken. The Br will come here, I will come over there. These are the two structural isomers that can be shown by this molecule. So when I draw, okay, I will just draw carbon, okay, carbon, IBr. This one, since I'm drawing using display formula, so I'll just draw all the hydrogen, and then CH. So I have I here, Br here, then the rest I'll draw the H. Okay, now identify the type of structural isomerism shown by the molecules in D3. So this one is going to be positional, different position. Okay, so this is going to be positional isomerism. Okay, now explain why the two structural isomers do not form in equal amounts. Okay, they do not form in equal amounts because, okay, we need to check, okay, because this is going to be, okay, if you look at, okay, the formation of the carbocation, okay, we know that, okay, if you look into the structure, okay, so you have this. So when I react with IBr, okay, IBr, iodine and Br, okay, we know that the more electronegative element should be the one that can attract the electron the most is going to be Br. Okay, because iodine is lower in the group, so therefore they have more number of shells, so they cannot attract the electron to itself. So this will be delta negative, this will be delta positive. Okay, and then okay, the one that will be the electrons will be attracted towards the delta positive. Okay, so when the electrons are attracted to the delta positive, okay, what happens? Okay, they can similar like what we did for HBr, for example. Okay, we have delta negative, delta positive. The delta positive will always go to be, remember, the rich becomes richer. Okay, so here you have hydrogen, 2 hydrogen and 1 hydrogen. Delta positive will go for the part that has the most hydrogen. They will go to this position. So what happens? They are going to form, okay, the I will go here, okay, and then this, okay, will form a carbocation, which is going to be, in this case, okay, is going to be a secondary carbocation. Okay, so you see secondary carbocation. If you follow with Br, it will form the primary carbocation with O1. Okay, so in this case, okay, they do not form in equal amounts. The majority of the product, okay, will actually go to this position, and then, okay, then only you have the Br over here. So the Br, okay, should be somewhere in the middle. So this is majority, okay, the major product, okay, and this is going to be the minor product. So if you explain, okay, you just need to explain that the secondary carbocation is favored, okay, is favored as, okay, as CH2, okay, CH2I, CH3 plus, okay, is favored. Okay, electrophile, okay, electrophile I, okay, electrophile I approaches the propene first, okay, approaches propene first, okay, because I and Br have different electronegativities. Okay, so because of that reason, okay, or you can say IBr is a polar molecule and they will actually favor the secondary carbocation. Okay, so that. Okay, question number 4. Okay, figure 4.1, okay, shows compound J to M, okay, containing 4 carbon atoms. Table 4.1 gives the details of the test J to M. In each test, only 2 compounds, okay, give a positive result. Okay, so only 2 compounds, okay, give a positive result. So observation, okay, of positive result. Okay, so J and L give positive result, okay, with acidified oxidizing agent. Okay, J and L, aldehyde, okay, and then this is a secondary alcohol, aldehyde and secondary alcohol. Okay, so aldehyde and secondary alcohol give a positive result. So ketone, okay, and carboxylic acid cannot be oxidized. Okay, good. So observation of positive result. Okay, because acidified potassium dichromate is going to be orange. Okay, orange change from orange to green. Okay, orange to green. Okay, color is observed. Okay. Now, alkaline I2, yellow precipitate. Okay, the compounds that can give you triiodomethane reaction is, okay, any of this compound. If you have like this, okay, any R group, Or if you have alcohol, then they must have CH3, they must have hydrogen, they must have R group. So let's actually look for carboxylic acid first. Okay, carbonyl compound first. Okay, it has CH3 here, possible. Okay, and then this is not possible. Okay, this is not possible. Okay, because no CH3. So here alcohol, it contains CH3 here, it contains hydrogen, it contains R. So K and L. K and L. Okay. Now orange precipitate, okay, J and K. So if you look at J and K, so it's going to be aldehyde and ketone. Okay, so aldehyde and ketone orange precipitate is 2,4-DNPH. Okay, just write the simplified version DNPH is okay, 2,4-DNPH, okay, or 2,4-dinitrophenylhydrazine. Yeah, with sodium, okay, with sodium, so the compound that will react with sodium is this and this. Okay, ketone do not react with sodium, aldehyde do not react with sodium, L and M. So L and M. Okay, if you react with sodium, okay, they are going to give you effervescence, okay, of hydrogen gas. Okay, you can mention just effervescence is okay. Okay, but if you test the gas, it will give you the pop sound with lighted wooden spring. Yeah. K reacts with ACN, okay, in the presence of KCN, forming N. Okay, so complete figure 4.2 to show the mechanism of this reaction. So K is going to be a ketone. Okay, so I'll just write down, okay, ketone. So okay, 1 2 3 4, 1 2 3 4. Okay, this is K, so it's a ketone. Okay, so this one is going to be nucleophilic addition reaction. Yeah. Okay, carbonyl compounds will undergo nucleophilic addition. Complete to show the mechanism. So first, what will happen? Okay, the electrons from here to here, it will go. So you will get delta negative, delta positive. Because delta positive, this will go in. Okay, so you will have CO because the electron went there. Okay, the 2 electrons you put over there, negative. And then C2H5, CH3. And then Cn already formed the bond, and what happens next is going to be HCN. Okay, must show HCN, yeah, because this one coming from KCN catalyst. So this one HCN, what happens, because of Cn is going to be more electronegative, delta positive. So here it will go here. Okay, what's going to happen? The H will come out, so you will have this plus. Okay, you will have Cn dot minus. Okay, now identify the class of a compound, okay, which N is a member. Okay, this is going to be hydroxynitrile. Okay, hydroxynitrile. Okay, hydroxynitrile. Now, so I think hydroxynitrile, so you want to put it here. Yeah, hydroxynitrile. Now N has a chiral center. Explain what is meant by chiral center. You see, chiral center is something that has 4 different groups attached to it. Okay, so chiral center, okay, is an atom. Okay, it's an atom or carbon that has, okay, 4 different groups attached to it. Okay, so that's it. Okay, the paper is done. See you.